Hey everyone, Dave McKay here again. We're going to do a second tutorial on balancing equations. I'm going to actually use the same kind of example, the reaction of hydrogen and oxygen, but show you a slightly different way of balancing the equation. So let's start with H2 plus O2 gives H2O. Now you already know the problem with this. At the moment we've got 2 atoms of oxygen here, and after the reaction's completed we've got 1 atom of oxygen here. In other words, we've lost, or what it looks like, we've lost an atom. And previously I showed you a way of balancing this up where I can put a 2 here and a 2 here, but there's another way of doing it. And what you do is you look at this oxygen here and go, well look, I only need to have 1 oxygen here. Can I somehow change this so this represents 1 oxygen? And the answer to that, of course, is yes. Again, you've got to use coefficients, but if I put a half here, you can see immediately what's happened. We've got a half of 2, which equals 1. So now I've got 1 atom of oxygen here, and I've got 1 atom of oxygen here. So to balance it all up, or just to double check, we've got 2 hydrogens, 1 oxygen, 1 oxygen, so the equation is actually balanced. Now we did that in one step. It's sometimes handy to do it this way, probably not with an example like this, but with some other ones that can be a little trickier to work with. Anyway, we haven't quite finished yet because no one writes equations with these fractional coefficients. We've actually got to turn them into whole numbers. So to do that, it's just a case of looking at whatever the denominator is. In this case it's at 2, and you multiply the whole equation through by 2. So tacitly written here, of course, is a 1, so this is 2 times 1 is 2. So I can write this as 2H2 plus, now 2 times a half is 1. So I can write that as O2. Tacitly there's a 1 there, of course. And I've got to multiply the whole equation through by 2. So I've got to put a 2 in front of their water as well. And there we go. I think that equation's balanced. Again, double check. 4 hydrogens, 2 oxygens, and 2 oxygens. So the equation's balanced.